In this video, we will learn how to factor the difference of two squares. First, let's derive the expression for the difference of two squares. Recall from multiplying binomials using the FOIL method, this particular example. Let's say we have to multiply the binomial x plus y with the binomial x minus y. Using the FOIL method, let's multiply the first terms, x times x, that's x squared. The outermost terms, x times negative y, that's minus xy. The innermost terms, the inner terms, y times x, that's plus xy. And the last terms, y times negative y, that's negative y squared. We can simplify this expression by cancelling out the second and the third terms because they add up to 0. So we get x squared minus y squared. This expression is the difference of two squares. We have minus here to indicate the difference, and both terms are perfect squares, meaning for each term we can get a square root. According to the derivation above, the factors of this expression consist of two binomials in which the terms are simply the square roots of the corresponding terms in the given binomial, such that x here is the square root of x squared and y here is the square root of y squared. Then we copy x and y into another set of parentheses and put plus and minus to indicate the sum and difference. In other words, or simply put, the factors of the difference of two squares consist are the sum and difference of the square roots of the corresponding terms in the given binomial. Before we consider an example, let's remember the first step in factoring any given expression, that is to factor out the common monomial factor. First example, let's say we have to factor x squared minus 36. The first question is, do we have a common monomial factor? The answer is no, because we have here the number 1, and on the second term we have 36. Okay, the second question is this binomial a difference of two squares? Okay, let's check. You have here minus for the difference. We can get the square root of the first term. We can also get the square root of the second term. So this is a difference of two squares. To factor, let's get the square root of x squared. That's x. Simply divide the exponent by 2, remember? Get the square root of 36. That's 6. Then we copy x and 6 into another set of parentheses and put plus and minus for the sum and difference. Second example. So we have to factor 3m squared minus 12n squared. Okay, the first question is, do we have a common monomial factor? Yes, because we have here 3 and 12 here contains 3. So we have to factor out the number 3. If we do that, what's left of 3m squared is m squared. And to factor out 3 from 12n squared, we have to divide 12 by 3. So we get 4n squared. The next question is this binomial a difference of two squares? Let's check. So we have here minus for the difference. We can get the square root of this first term. We can also get the square root of the second term. So this is a difference of two squares. To factor, let's copy the number 3. Okay, get the square root of m squared, that's m. Simply divide the exponent by 2. Get the square root of 4n squared, square root of 4 first, so that's 2. Square root of n squared, that's n. Copy m and 2n into another set of parentheses, and then put plus and minus for the sum and difference. Third example, let's say we have to factor 25p squared minus 16q squared. The first question is, do we have a common monomial factor? Well, no, because 25 and 16 do not have a common factor, and the variables are different. The next question is this a difference of two squares? We have here minus. We can get the square root of the first term. We can also get the square root of the second term. So this is a difference of two squares. So to factor, let's get the square root of 25. That's 5. The square root of p squared, of course, that's p. Okay, square root of 16, that's 4. Square root of q squared is q. Then we copy 5p and 4q into another set of parentheses and use plus and minus for the sum and difference. Fourth example, let's say we have to factor 16x to the 4 minus 9y to the 4. First question is, do we have a common monomial factor? The answer is no, because 16 and 9 do not have a common monomial factor. And the variables x and y are different. Okay, next question. Is this a difference of two squares? We have here minus. We can get the square root of the first term. We can also get the square root of the second term. So this is a difference of two squares. To factor, let's get the square root of 16. That's 4. Square root of x to the 4. Simply divide the exponent by 2. So you get x squared. Square root of 9 is 3, and square root of y to the 4, again divide the exponent by 2, that's y squared. We copy 4x squared and 3y squared into another set of parentheses, and then we use plus and minus to indicate the sum and difference. Now we have a reminder here, that is to determine whether a factor, especially the difference factor, is another difference of two squares. For example, in this problem, once you have written the factors such as these, you have to ask yourself whether this difference factor is another difference of two squares. Okay, let's check. You have here minus. We can get the square root of this, but can we get the square root of the second term? No, because 3 is not a perfect square. Therefore, this is not a difference of two squares, so we need not factor this further. Last example is, say we have to factor 16 times a to the 8 minus b to the 4 to the 4th power. Okay, first question, do we have a common monomial factor? 16. We have here 1, so we don't have any common number, and the variables are different. Okay, next question. Is this a difference of two squares? Let's see. You have here minus. We can get the square root of the first term and also the square root of the second term. So this is a difference of two squares. To factor, let's get the square root of 16. That's 4. Square root of a to the 8, a to the 4, b to the 4, that's b squared. Let's copy 4a to the 4 and b squared into another set of parentheses and put plus and minus for the sum and difference. Okay, so as this reminder suggests, we have to determine whether this difference factor is another difference of two squares. Let's see. You have a minus. We can get the square root of the first term. We can also get the square root of the second term. So this is a difference of two squares, which means we have to factor this binomial further. To do that, let's copy the first factor. Then we get the square root of 4, that's 2. Square root of a to the 4, that's a squared. Square root of b squared, that's b. Then we copy 2a squared and b into another set of parentheses. Then use plus and minus for the sum and difference. Okay, next question. Is this a difference of two squares? Let's see. You have your minus. Can we get the square root of the first term? No, because 2 is not a perfect square. Therefore, this is not a difference of two squares, so we need not factor this further. That's it for today. If you have any questions, please leave a comment. If you find it still challenging to get the square root of a given expression, please refer to the video on how to get the square root of an expression.